Okay, I had some requests for some help with probability. And sometimes these are difficult problems at first, and so I thought I would try to steer you in the right direction. Um, just remember, like in general, okay, E is an event, and the probability that something happens is going to be a fraction. And the denominator, this is going to be the larger number, right? This is going to be the largest number possible, really. It's the size of the sample space, right? What are the total possibilities? That number I'm going to put in the denominator. And then the event kind of defines what's going into the numerator. Okay, we'll look at that in a minute. But if you're stuck, it says find the probability. Look at, one of the things you can do if you get freaked out, look uh, at all your problems is this says find the probability of what? Of this. This one down here says, what is the probability? Okay, so look for the phrase that's going to tell you what to look for. And then maybe you could just start by, putting this down. Okay, and that at least would get you started. So let's look at this first one here. A probability experiment consists of rolling a six-sided die, numbered 1 to 6. Find the probability of the event below, rolling a number less than 4. So, maybe I should just start like this. Okay, and E is this. It's what they're asking you for. Okay, so I've got to find these two numbers. This bottom number is going to be the total number of possibilities. If it's a six-sided die, then this number is going to be a 6. If it's an 8-sided die, this number would be an 8. If it was a deck of cards, a full deck would be 52. Okay, so this is the largest number. And then the event defines how many possibilities we have in the numerator. So in this case, rolling a number less than 4, that's going to be 1, 2, and 3. Those are the possibilities, and there's 3 of them. So this is 3 over 6, and that's equal to 0.5. Okay, it says 3 decimal places there. All right, so try on a classical probability problem like this. It's a matter of finding what are the total possible outcomes, and then how many are there in what the problem is asking you to find, and that's the numerator. Now, if it's empirical, that means there's going to be a chart like this. All right, so once again, here we go. All right, we'll start there. We're going to start there. The bottom number, when you have a chart like this number here is the total possible number. Like, so you're going to add all of these up. This is they conducted a survey to determine how prepared people are for long-term power outage. Right? How prepared are they? And so they got a group of people, and this is the total number of people they interviewed. Let's see. So that's 280. I'm going to add all these together right here. So 280, 935, 535, 325, and then 53. So I'm just adding those. So I got 2128 down here. If I add those together, it's 2128. That's going to be my large number in the denominator. Okay, now this E is going to define what I'm going to put here. What is my E? What is the probability that the next person is going to be very well prepared? That comes in this group, which is the 280. All right, so I'm going to have 280 divided by 228 is 0.1316. All right, and that's the 0.132. Okay, so these are the two general types that you're going to have. You're going to have a fraction, and the bottom's going to be the total number in this case, the total number of possibilities. And then if there's a survey or an empirical problem where they have a chart, then this bottom number is going to be the sum of all these. You're going to add up all of these to get that bottom number. Okay? All right, so let's look at this one. Okay, so this problem here, is from the next section. All right, and it's about the multiplication rule. Let me just talk to you a little bit here on that. What's the difference between the first lesson and the second? The second lesson, there's more than one event. And you have to find the probability that all of the events occur. And so from your previous videos, that is going to be found by multiplying the probability of each event. And, you know, if you think about it, every time you add an event and you're looking for the probability that all of them occur, it's going to decrease the likelihood. In other words, you know, what's the chance that I'm going to get hit by a car today? All right, and then on the way to the hospital, there's a train wreck. You know, all those things. If I start adding up all those things, the probability that all of those things happen is very small. Okay, so and you multiply the probabilities. Let's look at this. All right, so the key word to know when you use the multiplication rule is and. All right, so right here you see and. Find the probability of tossing a tail and rolling a number greater than 3. All right, now how am I going to find that? Well, let's see, a tail and a 3, a greater than 3, okay? That's going to be the probability of rolling a tail or tossing a tail times the probability of rolling greater than 3. Okay, this is the multiplication rule. And so you might want to, like, if you don't have an idea, maybe you could just start right here. Okay, at least put this down and then try to figure out, okay, this is the first event. Let's concentrate on tossing a tail. All right, so how many possible outcomes? There's 2, heads or tail. And the one I'm interested in is the tail. It's just one outcome, so 1/2. What about this one? A 6-sided die. So the total possibilities are 6. And then rolling a number greater than 3. Greater than 3 is 4, 5, or 6, right? So there's 3 possibilities here. All right, so that's going to be 3 out of 12. If I multiply 2 times 6, I get 12. So was that a quarter? 3? All right, 0.25. All right, 0.25. All right, now this one, all right, this one is about conditional probability. Conditional. It says, here we have credit card carriers, and in this column we have not credit card carriers, so they don't own a credit card. And this row here is a freshman, this row is sophomore, and this is the total, right? The 100 total. If a student is selected at random, find the probability that he or she owns a credit card given that the student is a freshman. All right, so here's how you write that symbolically. All right, this line means given. So what's the probability that he or she owns a credit card given that the student is a freshman? Okay, so how do I do that? Well, if I look at this chart here, the freshmen are these. It's this row. All right, the 23, 37, all the people in this row are freshmen. So given that there are freshmen, all right, that's, again, the largest number in this row is 60. what's the probability that they own a credit card? Well, that's going to be the number of possible, they could be one of these 23 possible people, right? So it's going to be 23 over 60. If I do that, 23, 60.3833, okay? So let's look at this again. What would be the probability that I have a sophomore given that they don't, not a credit card holder, right? So this is where I start. This is given, so I know I have to start with that. Well, where are the people that do not own a credit card? They're right here, right? This column. So that means I'm given that I'm in this group of people here, 72, the largest number, right? What's the probability that they're a sophomore? Okay, that's going to be 35. See how that works? Okay, so that's, I don't know, sorry about that. I was a little off the page. Let me go through that again. If they're not a credit card holder, that means they're in this column here. These people are credit card carriers. This middle row are sophomores. This top row are freshmen. Okay, so if I start with this, given that they're not a credit card holder, they're going to be in this group of 72, like the largest number there. What's the probability that they're sophomores? 35 over 72. Okay, so I hope that helps. Let's go to this last one here. And so this problem here, there's several on the homework, and there actually on the test there's one like this. Hold on, let me get this, and I will. Okay, so here's the last problem I wanted to go over, and there's several problems on the test and homework like this, and there's 3 parts to it, and I want you to recognize when you get this problem. Okay, let me read it to you. In a sample of 900 U.S. adults, 191 think that most celebrities are good role models. All right. 2 U.S. adults are selected from this sample without replacement. Complete parts A through C. All right, so let's do part A. Find the probability that both adults think celebrities are good role models. All right. So both is like an and. Both the first and the second adult think they're good role models. So I'm going to multiply. And so maybe I'll even just put the probability of both and start here. Okay? So I guess why am I doing that? Because if you write me and say, I don't understand anything, well, at least make these parentheses and then try to figure out the numbers in there. All right? So let's just look at this first event. That's when the first person is selected from the sample, and they think celebrities are good role models. So how many are there? There's 900 adults, and what's the chances that I pick one that thinks it's a good role model? That's going to be 191. All right, so there's the first adult. And now let's try to figure out this second one here. All right, so how many are left? It says without replacement. That's key. Without replacement. That means in this one, the person I picked out is not in the pool anymore. So this is 899 in the bottom. One less. And there's also one less up here. So there's only 190 left that think they're good role models. And if you do the math there, that's going to be 191 times 190 divided by 900 divided by 899 0.0449. Make sure like you can get these numbers in your calculator. That's 0.0449. All right, so that's the first part. The second one is find the probability that neither adult thinks most celebrities are good role models. Okay, So this is neither adult. Probability of neither. All right, again, we're going to have this. What's the probability that the first one does not think celebrities are good role models? Well, we're going to have 900 here. How many in this group here do not think they're good role models? Well, it's going to be 900 minus the ones that do think that. So that's 900 minus 191. 709. Okay, 709. Okay, so this is the first selection. Now, the second selection, once again, I'm not putting that person back in there. So I have one less than 900, 899. And then I picked one of these people out. So this is going to be 708. All right, so 709 times 708 divided by 900 divided by 899, 0.6204. And I think they're asking, so they're asking for 3 decimal places, so that rounds to 0.620. All right, so that's neither. All right, last part. It says, find the probability that at least one of the two adults thinks most celebrities are good role models. All right, the probability for at least one is equal to 1 minus the probability that none of them think they're good role models. Okay, and this is a general formula here, right? These are complements. At least one is a complement of none. So anyway, make sure that you know this formula here so you can do the problem. The probability of at least one is equal to 1 minus the probability of none. And the probability of none is when neither, which is actually part B, when neither, that's the same as none. So I'm just going to subtract the probability of part B, which is 0.620, and that is equal to 0.620, 0.380. Okay, so that's the answer to that last one there. What I want you to see here is there's 3 parts to this problem. Both, neither, and then at least one. And when you get this type of problem, at least one, you know you're just going to take what you got in B here and subtract it from 1 to get the last at least probability of at least one. Okay, so anyway, I hope that helps you out. Sorry for the interruption in the middle there, but if you have any issues, be sure and write your instructor.